A team of Chinese scientists has developed a steel production method that is 3,600 times faster than traditional techniques. This innovation uses pure oxygen instead of coal, significantly reducing the carbon footprint of the steel industry. As the world's leading steel producer, China could strengthen its position with this more environmentally friendly and economical technique. The repercussions of this advancement could transform global steel market dynamics and encourage more sustainable industrial practices. China, known for its industrial innovations, has recently achieved a major breakthrough in steel production. After a decade of intensive research, a team of scientists has developed a method that eliminates the need for coal and is 3,600 times faster than conventional methods. This discovery could redefine the global steel industry by offering a more environmentally friendly solution to a historically polluting sector. This development raises critical questions about the future of the steel industry, global competitiveness, and the environmental impact of such innovations. The absence of coal in this new process could play a key role in combating climate change, making this invention both socially responsible and economically beneficial. An unprecedented technological innovation, the new method developed by Chinese scientists takes a radically different approach from traditional techniques. Instead of using coal as a carbon source to convert iron ore into steel, this process involves injecting pure oxygen into molten iron. This technique produces steel in just 3 to 6 seconds, compared to the 5 to 6 hours required by conventional methods. This unprecedented speed is achieved using a vortex lance that injects finely ground iron ore powder into an extremely hot furnace. This injection triggers a rapid chemical reaction, generating droplets of liquid iron that transform into pure steel. This technological breakthrough was made possible by the dedication and persistence of Chinese researchers who worked tirelessly for over a decade. Their success is based on a combination of advanced material processing techniques and high-temperature chemical reaction management. By eliminating the need for coal, this method not only accelerates the production process but also reduces the carbon footprint of the steel industry, one of the most polluting sectors in the world. The method is also notable for its flexibility, as it can be applied to iron ores of varying quality. China, which has abundant low-grade iron ore resources, could now better utilize its local resources instead of relying on imports. This increased resource autonomy could strengthen China's position in the global steel market. Environmental and economic impact. Steel production has historically been associated with massive carbon dioxide emissions, primarily due to the intensive use of coal. The Chinese innovation could, therefore, have a significant environmental impact. By eliminating coal from the production process, this method could reduce the energy cost of steel production by 1/3 while significantly lowering carbon emissions. This reduction is crucial for China, which has committed to reducing its greenhouse gas emissions as part of its sustainable development goals. Economically, this new method promises substantial efficiency gains for steel producers. By reducing production time from several hours to just a few seconds, operational costs could be drastically lowered. Chinese industrialists, already global leaders in steel production, could further enhance their competitiveness. The savings achieved could be reinvested in other sectors, stimulating innovation and economic growth. In terms of global competitiveness, this innovation could alter the dynamics of the worldwide steel market. Countries continuing to use traditional methods may face disadvantages due to higher production costs and a larger carbon footprint. This situation could encourage other nations to adopt similar technologies to remain competitive. Advantages for Chinese industrialists. For Chinese industrialists, adopting this new steel production method could transform the industrial landscape. The speed and efficiency of the process allow for increased production capacity without requiring massive investments in new infrastructure. This agility is particularly advantageous in a market where demand fluctuates rapidly. Moreover, as the world's largest steel producer, China could solidify its leadership position by providing steel not only faster but also in a more environmentally friendly manner. Chinese products made from this steel could gain a competitive edge in the global market, particularly in terms of sustainability and cost. The potential for reducing energy costs by 1/3 is also an attractive prospect for Chinese producers. With lower energy costs, profits could be reinvested in research and development, fostering continued innovation in this key sector. This dynamic could also encourage other industries to adopt more sustainable practices, enhancing China's image as a responsible global actor. Global repercussions. The new steel production method developed by China could have implications far beyond its borders. As the world's leading producer, China influences global steel market trends and prices. The adoption of this technique by other countries could lead to a radical transformation of the industry, with implications for global supply chains. Countries heavily dependent on coal imports for steel production could find themselves at a disadvantage if this method becomes widespread. This could also affect coal-exporting countries, which may see a decrease in demand for their products. Economies reliant on coal exports might need to diversify their industries to compensate for reduced revenues. Additionally, this innovation could encourage the development of similar technologies in other energy-intensive sectors, contributing to a global effort to reduce greenhouse gas emissions. Companies worldwide could be incentivized to invest in cleaner and more efficient technologies, creating a ripple effect toward a more sustainable future. Challenges of large-scale adoption. Despite its many advantages, the large-scale adoption of this new steel production method could face several challenges. First, integrating this technology into existing infrastructure may require significant initial investments. Companies will need to evaluate the potential costs and benefits to determine the economic viability of the transition. Second, training the workforce to operate these new facilities could present a challenge. Mastering the new technologies and associated processes will require a skilled workforce, potentially necessitating specific training programs. Companies will need to invest in developing the necessary skills to ensure their personnel are ready to manage these new operations. Finally, protecting intellectual property and managing patent rights could also pose challenges. Companies will need to navigate a complex legal landscape to protect their innovations while complying with international intellectual property laws. International collaboration may be necessary to ensure that the benefits of this technology are shared equitably while encouraging continued innovation. By adopting this new steel production method, China could redefine global industrial standards. But how will this transformation truly influence the balance between economic growth and environmental sustainability?